All right, I'm back. I'm so sorry I lost whoever that viewer was. Hopefully you come back and kind of see this eventually after the fact. But essentially, and I have to call my internet company because this is really getting annoying now. So we get 2, 1, 3, 4, 5, right? So that's after one rotation. So cool. We finished step 1. Step 2, in this case, is to reverse the middle to the end of the list, 1 after this. So 1 plus 1 is 2, and then num's length minus 1 is going to be 4. So we want, in this case, to rotate from index 2 to index 4. So we're going to have to do that in 2 steps. So 2, 1, 5, 4, 3, and then it's going to be, well, I should say 2 iterations, but on the second iteration, it skips the while loop because we're on 4. Start and stop are the same, so we do no work. All right, so now we've got 2, 1, 5, 4, 3. Step 3 is to reverse the entire list. So it should become then 3. So let's do it the way, I mean, I could just write it out, but let's do it the way the algorithm actually does it. So in this case, it's going to be 3, 1, 5, 4, 2. And then it's going to be 3, 4, 5, 1, 2. And then we're done because start and stop were on 5, index 2, so there's no additional rotation required. So the answer, that doesn't seem right. That don't seem right at all. All right, let's step back and walk through the rotation again. That didn't seem correct. Okay, so 0 to remainder k. Remainder k in this case we discussed was 1, so it's the equivalent of 1 rotation. So when 1 rotation occurs, it's 0 to 1, so it should be 2, 1, 3, 4, 5. The next rotation should be just 3, 4, 5, so it should be 2, 1, 5, 4, 3. Okay? Then finally, we should rotate. It's off by 1. It should be. It's off by a lot, actually. Why is it off by so much? It's a sanity check, but I think something is not right here with this algorithm. Let's just run it though, just to confirm. Oh, sorry. Go away, remainder k. Yeah. So see how we have this undefined in here? So we're stepping out of bounds. Interesting. So where are we stepping out of bounds? Okay, so let's start by console logging the first step, and see if we get what we expect. Okay, after the first step, we get undefined 5, 4, 3, 2, 1. That is not even remotely correct. So what happened here? That's interesting. So what is remainder k at this point? So it should be 6. It should be 5. Oh. So you remember over here how we okay, so I see the bug now. So remember over here how we switched this because it's actually k we're subdividing? We made the same mistake over here. So k, it should be k modulus nums.length because we're reducing down k by the number of needless loops through nums, not the other way around. Now let's run the algorithm again. That's much better. It's not correct, but at least, and let's console log num k in this case to see what we actually ended up returning. So if we run this code again, we see that, yeah, it's 1, which is what we expect, right? Because it's 1 additional rotation, so it's rotation 1. So we know that this algorithm, or this the subdivider we came up with is correct. So if remainder k is 1, now let's run it again to see what nums is. So nums after the first step is 2, 1, 3, 4, 5, which is correct because we should be rotating 0 to 1 because the k rotation in this case is 1. So indexes 0 and 1 rotate. And then the next step we expect to do is that we then should be rotating the middle to the ends right? Which is what we've done in the previous problem. So let's take a look at this. So the second time we get 21543. But it's still going to be wrong. So what are we doing wrong in this case? Because if we're effectively only supposed to rotate 1, what I would expect to happen here what I would expect to actually happen, so I can kind of, all right, let's step back and think a second. Let me think a second about this. Interesting. All right, so I'm looking at the results again real quick, just a sanity check. I think for this to work, what we would expect this second value to be is it would not be 21543. It should be 1. No, that's still not correct. So what should 5 should still be in this location, right? Because it should be 43215 at the end of step 2, right? Because then when we rotate it back around, we'll get the 5, 1, 2, 3, 4, 5. So what that means is on the first iteration, we actually should be rotating from 0 to nums.length minus 2. So how do we arrive at that? What have we done wrong in this case when we have the overage case? Okay, so here's a cute little sanity case. If we put this to 1, does it even pass? It doesn't. So when we have a rotation of 1, it doesn't even work. Okay, so what that tells us is that it's not the overflow case that's wrong. It's the case when the number of rotations is 1, which is wrong. So now we need to sit here and think through why exactly that's the case. So let's think this through together. All right, let's try, just for fun, let me try some other cases to see if we've actually, so 2 is fine. Okay, so we're actually wrong in a lot of cases, right? So when it's 2, it works, but when it's 3, we see that we're also completely wrong. So something is wrong with one of the assumptions we've made. I think the reverse function is fine. What I think is wrong is potentially one of these. So my thinking is that we actually only want to reverse right before the number, and then we want to reverse to the end. So let's think through the implications if we make this change, how this would work. So my recommendation, honestly, is to start with 2 and then work back to 1. So we know the 0 case is unchanged, right? Because 0 greater than, basically if it's 0, it's still going to hit this condition, so we don't need to retest the 0 base case. So let's start by testing base case 2. So if we do step 1 with, so 1, let's type it out again, 1, 2, 3, 4, 5. Case 1, we're going to reverse from 0 to remainder, and then, of course, in this case, let me just put a note here, k is equal to 2, right? And I'm going to put some dashed lines so we have some sanity here so we understand what's going on. So in the first step, we're going to go from 0 to 2 minus 1, which is 1. So in the first case, we're going to get 2, 1, 3, 4, 5, right? Because in this case, we're reversing 0, 1, so we're just going to rotate the first 2 indices. Second case, we're going to reverse from remainder k, which is 2, through the rest of the list. So what does that look like? So 2, 1 is going to be correct. And then at index 2, which is 3 in this case, we're going to flip it. So it becomes 5, 5, 4 stays the same, 3. And then at that point, start and stop run 4, so we're done. And then we reverse the entire list. So it's going to be 3, 4, 5, 1, 2, which is actually the answer in this case, because if you rotate this twice over, this is going to become, Actually, is it right? Let's see. It's going to be 5, 1, 2, 3, 2, 3, 4. And then it's going to be 4, yep, 4, 5, 1, 2. Nope, it's still off by 1. Okay. I feel like for the two reverse functions, they should be within one of each other. It doesn't make sense for one to then be one because then one index kind of gets left hanging. So they should be within one of each other. So the question becomes, why is this still wrong? Okay, so we're going from 0 to 1 the first case, so that flips the first two.
There's nothing playing on this HomePod.
I probably should have muted Siri. I apologize about that. All right, so then let's think through here. 2, 2, 4. So 5. 5 and 3 get rotated. 4 stays the same. I am stumped, everyone. All right, so we're approaching the 15-minute mark on this stream. I'm going to give it a few more minutes. And if we're still not there, we might have to look at a solution to better understand what's going on. So let me think. Give me a second to kind of think internally, see if I can figure out another possible path for this. Hmm. 2, 4, so 3, 2, 1. Yeah, so we're off. We're off by 1 rotation, essentially. Okay. And just to check, in this case, okay, so this is for a case where it's 3, but if I do cases 2, it's still gonna fail, yeah. Oh, man. So case 2 works fine with the previous results, but case 3 fails. So let's try doing that little hack we did last time. We're not hacked necessarily, but maybe is the approach maybe potentially to do -1 minus k. So what happens if we do that instead? So in the second case, it's going to be, so if k is equal to 1, so 1 rotation occurs, we're going to get 2, 1, 3, 4, 5. And then for the second case, it's going to be 5 minus 1, which is 4, minus 1 again is 3. So then it's going to want to rotate from 3 to 4. So it should be 2, 1, 3, 5, 4, which becomes 4, 5, 3, 1, 1, 2. And that's for the case of 2 rotations, right? But that's not correct because it should have been this, so it's still not right. All right, so I think at this point I'm going to have to throw in the towel. So I hate doing this. So let me go back to the solution I believe it was. Let's take a look at one of the discussion solutions and then kind of figure out where we went wrong in this case. I think we're close. It's just I made one bad assumption somewhere, and I'm probably going to groan really loudly as soon as I figure out what it is. But that's okay. We're here learning, right? So, failing is just another way of learning. I think in Adventure Time, one of my favorite things Dog says is, sucking is the first step toward getting better at something, right? So it's okay. So let's take a look, and let's sort by most votes, because generally, it's not always a sign of quality, but it kind of gives you a little bit of a hint. Okay, so this looks pretty similar to what our approach was, right? So it's interesting, in this case, the developer simply assigns k to the modulus. And actually, that's fine in this case. That makes sense to me, right? Because if there's no modulus to, or if there's no need to subdivide, then it doesn't do anything. So this is a good change. I would agree with that. That makes sense to me, actually. The reverse function is the exact same. Now, the one difference I see here between what they did and what I did. Okay, so they start by reverse. So there's two differences. They do k minus 1 to k, and then they reverse the list to start. But I think you can actually reverse the list at any time. But let's see if that's the case. So if we review what they did -1, and then they did the list, and then they revert. So step 3 went to step 1, but let's see if I do it this way, whether I get the right result. And I don't. Okay, so maybe I've simply reversed step 1 and step 3. So, oh no, this is happening again. I start running out of memory after a while, which is really, really annoying. I need a new laptop, everyone. Let me kill some applications again real quick. All right, so I've killed as much as I can. Hopefully that helps the CPU a little. All right, so we're going to take step 1, and we're going to move it to step 3. And we're going to run the code again. It's still wrong. That's interesting. Oh. Because this should be 0, and then this should be... sorry. This should be 0, and then this should be to remainder k minus 1, and this should be from 0 to remainder k. So and then this final step is to reverse the entire list. So let's run this again. Still wrong. Okay, so let's move this back to the beginning. So what am I doing wrong? This should be, oh, yeah. Okay. All right. This is what happens when you're doing algorithms at almost 1:14 in the morning. You start making silly mistakes. But I just wanted to get this done for today, and I appreciate the viewer who's online for staying with me. I appreciate you so much. And in this case, this is, I think what's throwing me off is that my comments no longer match up to what's happening, so it's kind of throwing me for a bit of a loop, no pun intended. So this one is supposed to be from 0 to remainder k minus 1, and then this should be remainder k to nums.length minus 1. So we're going to go ahead and run the code. All right, so what did we miss? Our solution is clearly not matching the discussion, so let's go take a look at it again. We must have missed something, or I must have missed something, I should say. All right, so back to JavaScript, back to most votes, back to the fastest submission. So 0 to nums.length minus 1, that's good. 0 to k minus 1, and then from k, all right, so let's do this real quick, side by side, so we don't make the same mistake. And come back to the description, which is the tab where we have the active work. So let's compare algorithms. All right, so I'm not going to optimize the first case because there's really no need to. Why did you go away from what I was on? All right, go back to this. Okay, here's the solutions. Let's cross-check our solutions here. So the reverser runs until they cross each other, so that's correct. We're good with that. And then the first step is 0. Oh my gosh, this is honestly me being a little tired right now, I think. And now it passes. Okay, so just to satiate my curiosity, I want to know what happens if we go back to reversing the list at the very end instead. Yeah, it's wrong. Okay, so my base assumption was actually always wrong. Well, that kind of sucks, to be honest. All right, so let's run this code. So we pass. Let's go ahead and strip out the console log. All right, so let's test the 0 case. Let's test our corner, so 0. passes. Testing 1, passes. Test the length of the list, in this case is 7, passes. And then finally, let's finish checking this out by doing 1 greater than, passes. So pretty good confidence at this point to submit, and sure enough, we get the solution. So I don't even know if I'm allowed to show this, to be honest, but if we're not supposed to, I won't do it again. The explanation for how to do this, it's called cyclic replacement. So rather than kind of give away the premium code, let's kind of Google what a cyclic replacement is, which is the algorithm we implemented, or it's a version of 2-pointer we use today. So let's Google this real quick. Replacement, and let's, since we're not talking about vegetation, let's look at 2-pointer in this case. All right, so let's see if Geeks for Geek actually gives a decent explanation of this. Sometimes I like this website, but I found sometimes it's a little in their explanations, but let's see if we can kind of talk about this. So 2-pointers, this is known as cyclic rotation. We will bring the last element to the first and shift the rest in the forward direction. So start by swapping. I mean, this is again the solution we already came up with. I was hoping to have a better solution, but I know cyclic replacement is what we did. What I was trying to find was the actual, like, kind of an overall explanation of what we're trying to do. Because the cyclic replacement, I believe, is also used in linked lists, which we'll get to eventually. I'll get to eventually as well. So I think that's kind of more what I think the cyclic part comes from, talking about linked lists rather than necessarily the problem we just did. Although under the hood, you could think of an array as a singly linked list. And in fact, I believe I did implementations at one point in C++ where I created an array using a singly linked list. But that was a long time ago. All right, so this is just describing 2-pointer. I'm trying to see if this has an answer. Okay, so I don't think they're gonna give you the cycle solution away in this case, but all right. So I'll leave this to the reader. I'll see if I can do a reading of this and give a better explanation at another time. But essentially, in order to solve Leetcode 189 rotate array, what we used was cyclic replacement. And the algorithm is pretty straightforward to solve this, even though I butchered it horribly. What you do is you reverse the front of the list to the back of the list. So you basically reverse the entire list. Then you take the front of the list up to the index right below your rotation, and you reverse those numbers. Then you take the back half of the list, which is from the rotation to the index of the length, and you rotate it again. And by doing so, you will actually rotate the list about the rotation factor k, which is the intention of this. I know that's not a very satisfying explanation. I'm sure there's a proof or something behind this, but honestly, giving a proof and like doing asymptotic analysis and all that is probably a little bit beyond the scope of what I'm able to give you right now. But more or less, this would be likely the optimal solution to 189. The brute force solution would be simply to create a large for loop and essentially rotate through. So basically, you would just keep shifting numbers by 1 until you got to k, and then you'd be done. Or you use the little remainder k hack, where you take the modulus and then you basically rotate it by the moduluses. So, but you have to remember, in some cases for big numbers, that could be poorly performant, which is why we leverage 2-pointer, because 2-pointer is 3 folds of the array versus potentially having to go through multiple iterations of for loops, which could get you into O of n squared territory. At least this is O of 3n, because in the worst case scenario, you rotate only the length of the entire list. Well, actually, in this case, it would be the length -1, because if the rotation factor is equal to the length of the list, then you do no work, because you hit the line 8 case, which is where k is equal to 0 after the remainder does. All right, so I think that's it for tonight. Thank you so much for sticking around and watching me flail a little bit on this, but at least I do understand how to perform cyclic replacement algorithm to solve the solution. But I think offline, and to you, the viewer, and to myself, we should work on finding a good explanation for what cyclic replacement is and kind of how it came up with. Because, yeah, to me, I'm not necessarily grokking how this solved this problem. But at least we solved it once, and probably given the problem again, we could come up with a solution. All right. Thanks so much, everyone. Until next time, have a good day or night, depending on where you are. Bye-bye.